Okay, so this is the re-recording of week 9 discussion session. So the last discussion session that we had done in last yesterday, there was some issue with the sound, so that's why I again re-recording the session, and I'll discuss the topic as I have discussed yesterday. Okay. So in the week 9, you learned about this LDA topic modeling and all this thing. So this week discussion is all about this thing only. So if you see in your assignment tutorial assignment questions, so there are some questions related to LDAs and there are some numerical questions. So we will only discuss about the numerical questions. Before going through the numerical questions, we will briefly discuss about the LDA assumptions, and although we'll give a small brief about this Gibbs algorithm, Gibbs sampling, and then we'll do this numericals, and then at the end we'll discuss the tutorial Python code, how we can use this LDA in Python and for topic modeling and all this thing. Okay, so without wasting any further time, so let's start. Okay, so let's as I don't have the writing pad today, so what I thought, let's take a blog from Google. So this blog is from Medium by this writer, and this is so there are a number of such blogs are available, but I thought like this blog is quite easy to understand, that's why I take this thing. So you can also go with other blogs and all these things. So I will go through this blogs about how Gibbs sampling works, so it will give you some basic idea. So if you have some doubts about this Gibbs sampling and all earlier things, so I hope after going through this thing you will have some idea about how things work. Okay, so let's begin. So what is the assumption of LDA? So what is this topic modeling first? So the topic modeling is that basically it's a, suppose I give you a document and you want to you will tell me so what are the different topics present in that document. Okay, this is the topic modeling task. Now so how will you do that in unsupervised? Suppose you don't have any trained data. So suppose there are no tag corpus. So previously in the supervised learning, what people do is that there are some tag corpus where, suppose in this case, maybe there are certain documents and all these documents are tagged for certain topics. Then it is very easy for you to guess. For a new document, it is very easy to guess the topic for that document. But suppose those tag corpus is not available for to you, so how will you model your topic model, like this topic modeling thing? So how will you, so given a document, how will you tag the topics to it? So in that case, this LDA come into picture. So what this LDA assumption is that? LDA assumption is that there is a two-step process. So first thing is that LDA assume ki each of this document is made of certain topics. So it's a mixture of topics, and then the next step is that these topics are a mixture of words. Okay, so you can just see the hierarchy. So first thing is that this topic, these documents are constitute of these topics, mixture of these topics, and these topics are mixture of words. Okay, and according to that, like, so this is the assumption. Now how will you predict the topic of a document? So basically the thing is that you after doing these things, you will have for each of this word in a document, you will for each of these word will get a class, so topic class. So before running the algorithm, we will define, so what is the how many numbers of topics are will be available in your classification. So you need to tell that beforehand. So the algorithm cannot do it by itself. So you need to tell, so what are the how many numbers of topic are available before going before starting the algorithm. So suppose you tell ki okay, so I have only two topic class. Then how this algorithm works? So as algorithm try to classify each of this word of a document to any of these two classes. Okay, and this is how it is any of these classes, and then this algorithm works, and for each of this topic each after running the algorithm, you will find for each of this topic, so they have some particular numbers of words which are highly frequent in this topic. Okay, so highly frequent in this topic, for each of this topic class you will find. Now if some new document will come, so then in the according to the words in the document, you can predict what is the class of the whole document. Because like suppose someone gives you a new document, so then how will you predict? So then you already know that for each of these topics some words are more frequent than others. Suppose suppose there are, if in your new document there are words which are mostly from topic 1 class. So then you can predict, okay, so if in a document, so most of the words are from some certain class, then maybe the whole document is more probably from that class only. Okay, so it's kind of a and also there can be another possible. So the document can be mixture of topics. It can be mixture of topics. So maybe a document can be mixture of sport class, or maybe or entertainment class. Maybe that example, that one example you can think of, like this some document related to this IPL opening ceremony. Okay, so it's a kind of a mixture of entertainment and sports. Okay, so you will find some words related to sports and some words related to entertainment. So so to predict the class of the whole document, if you go through all these individual words, you will get some words are from this sports category and some from this entertainment category. Then according to that you will find, okay, so maybe 40% are from entertainment, 60% are from sports. So maybe this document is from there are two topics belong to documents, so entertainment and sports. So this is how things work. So it can be like maybe in some documents, so there will be only one topic which is prevalent. Okay, so maybe in the document there are 1,000 words, maybe among these 1,000 words, maybe 6,000 words belong to some class, maybe then 10 words belong to some class, then 10 words belong to some class. Maybe, so there you can see a tail distribution, so a skewed distribution. So for one class the probability is very high, for the other class the probability is very low. So then you can tell, okay, so the total probability is kind of for this class only. So how will you model this thing properly? How will you model this thing properly? So how we can do this? Okay, so yeah, so let's so for that thing, so this Gibbs sampling come into play. So so you need to estimate the model's probability. So yeah, so this is the thing. So given a word in a document, so what is the probability it belongs to the topic class J? Okay, so what is given, you know, so the only assumption is that you know all the topic class for all the other words. So you know all these things. So this Z minus I is that you know all these things, and this Wi is the count. You know the count for each classes and all these things. So all these things are already known, but now you want to predict the class for a particular word in a document. So suppose in a document 1, so what is the probability of a word W for the class, maybe some class, maybe topic class 1? Then you can use this formula. So if you see the formula, it's this is same. This is two this is a two like hierarchical thing. So one is from document term, and another is from word term. So what is this document term? So basically the thing that we have discussed. So each the document below like the document is a mixture of certain topics. Okay, so document is a mixture of certain topics. So you can get this from this matrix, and the topics are made of words. So this is from this topic, and if you multiply those formula, you can get the probability for the word belong to some topic class given the document. Okay, so this is how you can do that. So basically ultimately after running the algorithm, you will get a distribution of the probability class of a probability. Like for a topic, you will get the probability of the word. So suppose if you set up in your whole documents, all documents, there are only two topic class. Then after running the algorithm, we will get for these two topic classes, we will get a probability distribution for each of these words. Okay, so each of these words. So what, like, for maybe for topic class 1, maybe cricket is a high probable thing, so then football or something like that. In the topic class 2, maybe song is a high probable word, then something like that. So you will get all this probability for each of this topic class. So now we will have this for each of these topic class, you will have the word distribution. Then if someone gives you a new document, then you can predict the document class from this word class distribution. So this is the intuition. Okay, so how you get the, basically, so now the problem boils down to how you get the word class. So the topic class for each of this individual word in a document. Okay, so this is the whole thing. So for this thing, you need to use this formula. If you recall, you need to calculate this formula. So first thing is, like, it will calculate this word term matrix, and then this is a document term matrix. Okay, so how will you calculate this thing? So let's see a small toy example. Okay, so suppose this is the thing. So how this algorithm works? So suppose in your document, so these are the two documents. So basically these are the words, but for the time being, so just assume these are documents. So the first document is that the president declared war against Russia, and second is the student slept instead of studying for his exam. Okay, these are the two documents. Now we need to so these are the document, and I need to classify the topics for the whole document. And also so how will you classify say a document? So basically you need to classify each of these words. Then suppose, just I'm giving a just rough estimate. Suppose in a document, if there are 100 words and maybe 50 words belong to some topic class, maybe it's more probable that the document is belong to that class only. So basically the problem now is that how will you classify the words for a particular class. So that is how this algorithm calculates. So okay, so these are the two these are the document class 1, these are the document class 2. Now the thing is that now you can see, so actual word is this, but after the some kind of regularization, or this stop word removal of this stop words in punctuation removals, and then stemming, lemmatization, all these things, these are the modified words. So why people do this thing? Because, like, this stop words, these things don't have that much of impact in final task. So basically just think of this scenario. So you are trying to predict some sentiment prediction. Suppose a sentence is a positive or negative plus or something like that. But if you see in your corpus, there are 100 words. If you see, most of the words contains the, is, all these things. So these words are present in positive class also, these words are present in negative class also. So these words are not very helpful to classify the sentence. So these words are called stop words. So these are very frequent words, but without any impact toward classification. But suppose there is a word good or bad or something like that, but these words are not that frequent, and the most frequently these words are belong to some like one of the classes. Maybe you will see the good maybe in the positive classes, or bad maybe in the negative classes. This is just an example, so it's not that like it will be like that only, but yeah, here's the thing. So that's why people remove those stop words and all these things. So after removing all these things, so this is the final like modified sentence. That this is the first sentence, that this is the second sentence. Okay, this is the first sentence and this is the second sentence. Now what you can do is that okay, now your system cannot identify word as like this this as a whole word, like president declared this. A system cannot identify the for identification, so you need some kind of numbering, so number or numerical values, or real numbers or something like that. You will need this thing. So how will you transfer this word like this to certain kind of number system? So so then what you can do is that you can map each of this word to a particular. So this is one of the method. You can do there are other methods like TF, IDF and all these things. You can do this, but yeah, for this example, for make it simple, just think for each of these words are represented by a unique ID. Okay, so this president is 1, declared is 2, word is 3, Russia is 4, student is 5, and so on and so forth. And in the examples, as there are no repeated words, so that's why for all these words there are each distinct ID, so there are no common IDs. Okay, so all these words are different. Okay, so now okay, so now this till this point all these things are fine. Now the next thing is that we need to declare how many topic class we are interested in. Okay, so we already know. So this LDA, before running the algorithm, we need to specify the number of topic class. Okay, so this algorithm cannot like deduct how many topic class probable or all these things. So you need to tell them before and give what are the how many topic class there should be, or something like that. So you need to tell this thing. So in this example they say okay, so in our case toy example, so maybe there are 2 topic class. Okay, the topic class 0 and topic class 1. Okay, now the thing is that, like what we have already discussed, we need to classify each of this. That is the main thing. So we need to classify each of this word from any of this class. So this is the thing. So so each of these, so topics are made of words. So that's why, so for each of this each of the word are from some class. So basically that is the main thing. So we need to identify what are the class this word belongs to in a document. Okay, if we can identify these things, then we can get the whole topic class for the document. So that's why we need to identify each of these each of these topic class for each of these document. But before starting the algorithm, we don't know anything, because this is not a supervised algorithm. This is an unsupervised algorithm, and we don't know any goal level. So that's why, so like at the beginning we need to randomly assign the topic class for each of these words. Okay, so as there are 2 topic class, as we have already decided, so let's randomly assign any of the topic class. Okay, so this is in the first document. First word assign the topic class 0, in the second word topic class 1, third word topic class 0, and so on and so forth. Okay, so this is the thing. So first word 0, second word 1, maybe say third word is again 0, fourth word is also 0. So that's why you already in the initial phase you decide the, okay, so this is the random initialization for this topic class. But this is not like it may, like as you are randomly guessing, it might not be true. So you need to get the what is the best prediction for each of these words. So how will you do that? So this algorithm, so this Gibbs sampling calculate these things. So how will you ultimately get a good approximation for each of these words? Okay, so each of these word and each of this class for each of these document. So if you remember, so we need to for that we need to calculate 2 different matrix. One is word topic matrix and one is document topic matrix. Okay, so what is this word topic matrix? What is this word topic matrix? So if you remember, so this is word topic matrix is like how many different words are there and how many topics are there. So basically it's a, like in our toy example, there are 9 distinct words, 1 2 3 4 5 6 7 8 9. So there are 9 distinct words and there are 2 topics. So it's a 9x2 matrix. So and what is this each cell represent? So basically it represents how many times this word present in the topic this. Okay, so if you see the first row, so how many times present in the topic 0 and how many times present in the topic 1. So how will you get this count? So from this initialization table. Okay, so if you see, this is your initialization table. So randomly initialize for each of this class, each of this word you will initialize the class. So how will you calculate this thing? So let's see what is the precedent. So precedent is the first word, and if you see, so it is assigned to the class 0, and there are no other precedent in your corpus. So there is no topic 1 class for the precedent. So That's why precedent is belong to the topic 0 class only once, and there are no occurrence of precedent in the topic 1 class. So that is 1 0. And in the similar way you will find for the other words also. Let's take another example. So student. Okay, so let's take student. So where is student? So student is the first word in the document 1. Okay, so first word in the document is 1. So it's initialized with the topic class 1, and there are no other occurrence of students, so there is no chance to assign for the topic class 0. So that's why the top student topic class 0 occurrence is 0, but for the topic class 1 occurrence is 1. Okay. So that's why how you make this word topic matrices. Now it's done. Now what is the second matrix? You need to calculate this dt. So what is dt? Document topic matrix. So how you make that? So as the name suggests, it's a document topic matrix. So there are 2 documents and 2 topics. So this is a 2 cross 2 matrix. So what this individual cell represents? So this individual cell represents in the document 0, how many words are from topic 0 and how many words are from topic 1. So this is what this matrix represents. So let's take this example. For document 0, they are saying there are 3 words from topic 0 and there are 1 words from topic 1. Let's calculate in the document 0. So this is the document 0. In the document 0, if you count the number of ones, there are only 1 word from the document on the topic class 1, and there are 3 words from the topic class 3. So that's why for in the topic class 0, so there are 3 words from the topic class 0 and there are 1 words from the topic class 1. So that's why if you see the matrix is there are 3 words in the topic class 0 and 1 word from the topic class 1. Similarly, if you check the document 1, check the document 1, there are 1 2 3, there are 3 words from the document class 1. There are 2 words from the document class from the topic class 0, and there are 3 words from the topic class 1. And if you see, so there are 2 words from the topic class 0 and there are 3 words from the topic class. So you already calculate this document this WT and DT matrix from this initial assignment for the topic class for each of this individual word for each of this document. Okay, this is the thing. Now what you want to know? Okay, so now you want to again check the probability for each of this class probability. Each of this, now you want to check is this assignment is correct or not, that you have assigned this value randomly, but after using this thing you calculate the after using this thing you calculate the this what this is thing you calculate the calculate this WT matrix and DT matrix. Now again you using this WT and DT matrix, again you need to check you need to reassign the values for each of this individual word. Okay, so how will you do that? Let's check. Okay, so so what we are discussing. Okay, now how will you calculate this thing? So suppose this is the value. Okay, so suppose this is the value. Suppose you again you want to calculate what is the topic class for the document 1 for the precedent. Okay, so again, so for the document 0, what is the topic class for the word precedent? Previously you assigned 0, but now again you want to recalculate this using this WT and DT value. So how will you calculate? Okay, so this is the formula. So if you just remember, this is the formula. So you need to get the WT matrix and WT matrix, and you need to get this thing. So just remember first to get the, so suppose in our case we want to know the topic class. We want to know the topic class for word precedent in the document 0, and what probability you want to know, is it suppose we want to know is it from topic class 0 or not, then we will calculate what is it from topic class 1 or not. So there are only 2 possibilities. The word can be in any of the 2 classes. It can be in the topic class 0 or it can be in the topic class 1. Okay, so first find if it is in the topic class 0. So then, so as per the formula, so j is 0 here, so then you need to calculate. Okay, so the precedent, so what is the count in the word topic matrix? the word president and topic 0, and then again you need to regularize using the whole sum. So if you see, so in the matrix, so president and topic 0 is count is 1. Okay, the president and topic 0 count is 1. So that's why the enumerator in the first part of the expression is 1. And what is the denominator? Denominator is this thing. So you need to calculate the sum for all j. So j is fixed, so j is 0, the topic 0, topic class 0 for all the words. So in the topic class 0, the count of all the words. So in the topic class 0, count of all the words. So 1, 2, 3, 4, 5. So there are 5 words. So that's why that summation is 5. Okay, so the first part is done. The next part is that you need to calculate this thing, the document topic matrix. In the document topic matrix, so what you want to see in the document 1, you want to predict the class probability of the topic class 0, as we are doing it topic class 0. So topic class, so D and J, so document is document 1 and J is the topic class 0. So let's see the count. So document 0, topic class 0, the count is 3. Okay, so that is the thing. And the denominator of the second part is that you need to sum over all the yeah, so all the term from this document. So di is fixed, but this term for this document, so what the document we are interested in, we are now searching for the document 0. So for document 0, we need to calculate the total sum. The total sum is 4. Okay, so total sum is 4. So that's why you can use this formula and put all these values. So eta alpha values are given, w is the total number of words in vocabs in your corpus, t is the number of topics. So all these things are given. Now we will get, okay, so 13%. So what this probability represent is, okay, it's saying ki the probability of the topic class 0 for the word president in document 0 is 13%, around 13%. Okay, so in same way you can calculate what is the probability of the word president in the topic class 1 in the document 0. Okay, so we will get the two, because like each of the word, each of this word, so each of this word can have only two possibilities. Either it can be in the topic class 0 or it can be in the topic class 1. So we already calculate the probability for topic class 0. Then you can calculate the probability of topic class 1. And among between those two probabilities, whichever is the largest, you can assign the you can reassign the probability. So if you see in the initial assignment, we assigned it as a topic class 0. But after this calculation, we see for the topic class 0, the probability is 13%. So obviously for the topic class 1, it will be much higher. So it will be around maybe 87% or something like that. So it is a high probability that this tag should be changed. Maybe will change. Okay, so in this phase we will change this 0 to 1. So maybe this president will tag to topic class 1 in the document 0. And we will do for each of these word for each of these documents. Okay, so we'll just do, for this example, we only do for document 0 president class 0, but for all this word we need to do that for document 0 second word, document 0 third word, document 0 fourth word, for document. Okay, so after all this thing calculated, again you need to calculate the WT and DT from the newly assigned matrix. So the value will be changed after this pass. Then again with this value you need to again calculate this WT and WT. Okay, so this WT, and because this WT and WT depends upon this assignment. Okay, again in the next phase again you need to calculate again, and so this phase will continue like till some certain point. Okay, then this after some time this will converge, and you will get this matrices, this the ultimate matrices where you will find these things. So for each of this word, each of this topic, you will get some kind of a some kind of a probability distribution. So basically this is 1 0. Maybe you will find what is the probability distribution. It is in the class 1 or it is in the class 0 or something like that. So that is important. So after running the algorithm, we will get this class distribution, for each of this topic, you will get the word distribution for each of this topic, and then if someone gives you a new document, and then you will read each of this document and check what is the most probable word topic class for this word in Fasta, and you will predict that document. So this is how this algorithm works. So this is kind of the whole flow. Yeah, so it can be like maybe it's a bit difficult, but if you just go through it, you will understand how these things work. Okay, so let's see the numerical problem of this week. Okay, so in this week, so they have given a numerical problem related to this Gibbs sampling. So they are saying ki suppose you are using Gibbs sampling to estimate the distribution theta and beta for topic models. Okay, and all what the other things are given. So the things are given is that, like, they are saying there are 3 documents. So document 1, document 2, document 3, and there are 5 words, like 5 words solid. So there are 5 distinct words: machine learning, language, nature, visions. And also you already know key before running the algorithm, you need to predefine the number of topics. So yeah, so also you need to already define in our corpus there should be maximum 2 topics. The 2 topics are given. Now this eta and alpha values are there. Now you need to calculate this parameters. So beta, nature 2. So, and if you see in the bracket, all the assignments are already given. So this nature belongs to the topic class 1, language belongs to the topic class 1. Maybe in the document 2, this language belongs to topic class 2. Some in the bracket the topic class are also mentioned. Now we need to calculate this thing. Okay. So what is this beta to nature represent? It represent what is the probability of the word nature belong to the class topic class 2. Okay, so this is the thing. So what is the probability of the word nature belong to topic class 2? So how will you do that? So yeah, so already have done this. So basically you need to make this topic like word topic matrix. So all the distinct words are here and the topics are here. So you already know, so there are 5 distinct words and 2 distinct topics, and you need to calculate and need to frame it. So what this cell represents, so how many times nature belongs to the topic class 1 and how many times nature belongs to the topic class 2. So this is how these values are calculated. So how you can calculate, let's see, check. So how many times nature belongs to the topic class 1. So if you see in the example, so nature 1, 2, 3, 4, 5. Okay, so there are 5 occurrences of nature, and all these occurrences nature is tagged with topic class 1. So there are no occurrence of nature where it tags to topic class 2. So so that's why this is how. So the count of nature is 5 for the topic class 1, and topic class 2 it is 0. Similarly you will find the other thing also. So let's check the language. So if you see the language, so language is 1. So 1 for, let's first count with the topic class 1. Okay, so 1, 2, 3, 4, 5. Okay, so there are 5 occurrences of language in the topic class 1. So there are 5 occurrences of the language in the topic class 1, and let's count the topic class 2. So language in the topic, yeah, so 1, 2, 3 and 4. So there are 4 occurrences of language in the topic class 2. So that's why you can build the matrix for the other so you can calculate the values for the other cells also. Now what is given, so you need to, so this formula already given. So here W is the total number of vocab, so W is 5 as there are 5 distinct vocab. Now the thing is that you need to calculate the probability given the word nature. What is the probability? It belongs to the topic class 2. So here I is nature, J is 2 according to the formula. Now we need to calculate the first numerator. Numerator is that CWT nature 2. So in the word topic matrix, you need to see the count of nature and 2. So what is nature and 2? Nature and 2 is 0. Okay, so that's why it is 0. And the denominator, you need to calculate the sum over this thing. So this sum over all this words. So j is fixed, so the topic 2 is fixed, but the the vocabs are changing, so we need to sum over all the words throughout this topic class 2. Okay, so you need to calculate all these words. So nature 2, language 2, vision 2, machine 2, learning 2, you need to sum. So if you see, so for the topic class you need to sum over all these words. So 4 plus 4 8 plus 3 11. So that's why this count is 11. Now we just need to put the value in the equation. So as per the formula, the numerator is 0. The eta value is given is 0.3. So this eta value is 0.3. Denominator, the sum is 11, then plus w is 5 into 0.3, and if you just calculate, it will be 0.024. So this is the first question. About this. Now let's move to the next question. So next question is that you want to estimate the value theta 21 given the document 2. Okay, so you need to calculate the value of theta t1 given the document 2. So what this thing represents? So it represents what is the probability of the topic class t1 in the document 2. So what is the probability of topic class t1 in the document 2? So the formula is given. So what you need to do, you need to calculate. Now you need to calculate the document term matrix, because if you see in the formula, to calculate the theta, you need to calculate this dt, document topic matrix. So there are, you know already, there are 3 topics and 2 terms. So you need to calculate each of these individual entries. So what are the entries? So given the given the documents, how many words are from the topic t1 and how many words are from the topic t2 in the document 1. Okay, so let's check. So in the document word, how many words are from topic 1? If you see in the document 1, so there are 1 2 3 4 5 6 7 8 words, and all the words are from document class 1. So there are no words from the document class 2. Okay, so that's why this is 8, 0. So there are 8 words from topic class 1 and there are 0 words from the topic class 2. And the document 2, there are 5 words from the topic class 1 and there are 3 words from the topic class 2. So you can see in the document 2 there are 1 2 3 4 5. There are 5 words from the topic class 1 and there are 1 2 3 words from the topic class 2. So that's why you can also similarly calculate for the document class 3 on also, and you will get this matrix. Now you need to calculate. So what they are asking? So they are asking to calculate theta t1 document 2. So what is now j here? According to the formula, j is t1 and d is document 2. So if as per the formula, so numerator c dt dj, so d is document 2, so d is document 2 and t and j is t1. So basically you need to see the count of document 2 t1. So document 2 t1 is 5. So document 2 t1 is 5. So that's why this value is 5. And what is the denominator? If you see in the denominator, d is fixed, the document is fixed, but k, the topic, is changing. So you need to sum over all the topic in the document 2. So you need to sum over all the document sum over all the topics in the document 2. So this is the thing. So document 2 t1, document 2 t2. If you sum over all these things, so 5 plus 3, it's 8. So 8. Now you just put the value. So 5 plus 3, so alpha is given 0.3, denominator is 8 plus number of term is 2 into 0.3. So if you calculate, it is 0.627, something like that. Okay, So what this suggests ki the probability of topic class T1 in the document 2 is 0.61 or 6 something. So this is clear. Now what is the next question? So next question asking what is the probability of the topic class T2 in the document class in the document 2. So if you see, so the questions are same, but for in the question 7, so it is T1, and question 8 it is T2. So basically if you see, if you just think of like this way, so there are only two topic classes, T1 and T2. Okay, so there are only two topic classes, T1 and T2. So a document can either belong to the class T1 or belong to the class T2, or mixture, kind of a mixture. So it's a probability distribution. So the total probability for these two will be 1. So this should be 1. So total a document can have it can be in the document class T1, or it can be in the document class T2 with some probability. So but the total probability should be 1. So because there are no other topic classes. So if you know the answer of the question number 7, you already know the answer of the question number 8, because it will be 1 minus the answer of this question number 7. So the question number 7 answer is 0. So if you 1 minus these things, it will be around 38 or something like that. Yeah, it will be around 38 or something like that. So maybe question 3 will be the answer. But if you think, okay, so you can also calculate it. So same thing. So here J is the topic, J is topic 2, document is same thing. So first in the numerator you need to check document to T2. So document to T2 is 3, and the numerator will be same. So it will be 5 plus 8. It will be 5 plus 8. If you just calculate the value, you will get that. Okay. So now you can understand for document class for the document document 2, this is the distribution for the topic class. Okay, so this is the distribution. So the total probability should be 1. So this is how you can calculate the whole thing. Okay, so we already discussed all these things. I hope these things are more or less clear. Now let's discuss about the coding part. So how you can use this LDA thing in Python, and how you can use in some kind of application, so something like that. Okay, so we have a toy example here, so we can just check, and you can I also give the link of this Google Colab in the YouTube video description. You can check it. So what is this thing? So at the beginning you will need to import all these things. If you just familiar with Python, you know you need to import all these different thing on this thing. Now the main part starts from here. So suppose this is our corpus. So in our corpus there are 8 documents. So again, the for the sake of understanding, think each of the sentence as a document. So there are 8 documents, and we need to classify the topics for each of these documents. Okay, each of these documents we need to. And if you just remember what we have talked in earlier, in the NLP, it's a quite common practice to, before passing the sentences to some kind of algorithm, we need to remove those stop words, punctuations, all these things, because those words don't have much impact in the final calculation. So it's always better to remove them. So if you remove those things, you will get, this is the clean corpus. So the first document is sky, blue, and beautiful. Okay, so basically it's not like this is a comma separated format. So the total words, like the sentence will be sky, blue, beautiful. And if you see the first example without the removal of the stop words and all these things, so the sky is blue and beautiful. So after the stop word removal, this the, is, and those are removed. Okay, so those are removed. So that's why only the sky, blue, and beautiful are removed. So similarly for the other words also. Now this is our clean corpus. Now the thing is that we need to because already discussed, we cannot pass the actual words to the model, because model cannot understand words. So we need to have some kind of a like real value for each of these words. So how we can do that? So there are multiple ways. So if you just remember, there are TF-IDF things, so term frequency, inverse document frequency kind of vectorization, or count based vectorization. So you can use those things. If you just forget how to do this thing, I recommend, there are amples of materials present. Just go through it. It will help you to understand how TF-IDF or this count vectorizer works. So these things are not very difficult. You can just check it. Okay, so after passing it to a count vectorizer, okay, so you can see. So suppose we are just checking the TF-IDF thing. So now you can see this is the after, if you pass it to a TF-IDF thing. So basically what TF-IDF do, TF-IDF transfer your actual sentence to a vector of some size. Okay, so and what are the dimension of vector? So how many total distinct words are there? So in this case, there are in our document, so maybe there are 22 distinct words or something like that. We can also limit this thing. So but for this timing, I hope there are only 22 words. So each of these sentences now will be represented by 22 vectors, 22 size vectors. And how this 22 entries represent for each of these words, so that is let's see. Okay, so you can check the you can check the size of this vector. Yeah, so you can see it is a 8 cross 22. So because there are 8 documents, and each of these document will be now be represented by this 22 feature vector. Okay, and what are these features? What are these feature vectors? If you just print it, you can see. Okay, so you can see there are, this is not represented as a like when I am printing, it is not showing the actual 22 dimensions for each of these words. But suppose this is the thing. So for this document 0. So document 0, there are only 3 words, 2, 3, 9, 19. So what is this 2, 3, 19? These are the index for the features. So these are the features. So if you count 0, 1, 2, 3, so this is 2, 3, beautiful and blue, and maybe 19 will be sky, because there are 22 words. So 19, 20, 21. So sky. So you can see there are beautiful, blue, and sky. So if you just remember, so in the first words, the first sentence, there are 3 words, sky, blue, and beautiful. Similarly, you can see in the in your after the TF-IDF thing also, the document 0 is represented by these 3 features, beautiful, blue, and sky, with some numbers, real numbers. And in this when you are printing, so you are only seeing these 3 values for the document 0, but actually there are total 22 value vectors. Only these three entries are some values, but for other entries the value will be 0. So that's why they not printed those things. So but actually it is a 8 cos 22 matrix. So for each of this document, there will be 22 vectors. Okay, 22 size vector. So only 3 elements are there from the vector, but for 99 or the remaining 19 entries are 0. Okay. Similarly for the document 1 also, you will find document 1, in the document 1 there are 4 words. So similarly you can also find all this thing. So this is how this thing works. Also similarly, if you just think, okay, TF-IDF, I will not go with this TF-IDF, I will go with this CV vectorizer. You can also do this thing. CV vectorizer is also same. It will also represent each of this of each of your sentence. Yeah, so each of your sentence, this is, if you see, each of your sentence with 22 value vectors. Each of this with 22 value vectors. If you want to print it, you can print the value. So again same. So the each of this document will be represented by 22 size vector. But like if you see in the first document, there are 3 words, as we have seen in the first example. But in the first example, we see that there are some real values. But in the count vector thing, so there are no real values. So if you remember what count vector, so it represents how many times word present in the document. So that's why this is 1, 1, 1. So the word sky present, how many times the word sky present in the document 1. So this is the count. So this is how they have represented this thing. And for the other entries, the value will be 0. That's why they have not represented. So basically the actual matrix is 8 into 8 cos 22, but yeah, this is the representation. Yeah, so this is the number of vocabs if you go with the same thing. Now you already have this thing. Now you can run your LDA algorithm with this representation, with this TF-IDF representation. Okay, so yeah, so if you see, if you remember in the LDA thing, what we have done in the before starting the algorithm, we need to define how many topics are there. Similarly, here also we need to specify how many components. So components basically the topics, how many topics are there. So we are saying, okay, so in our toy example there are 3 topics maybe. And what is this max iteration? So it is saying how many times this program will run. So if you just remember what we have shown here, each this value will be calculated again and again. So how throughout iteration. So how many iteration this algorithm will go on. So we say, okay, let's run this thing till 500 step. And random state, what this random state indicates? So when so in your model, so there are multiple parameters, but at the beginning, so the parameter will have some random values, because you don't know what are the exact values for these parameters. So how to assign the random values for this for all these parameters? You use this kind of a random state. Okay, so yeah, so through assignment of for this random value. Now you can just pass your TF-IDF vector. So what is this TF-IDF array? So it is basically the number representation of your whole corpus. Okay, so you represented your corpus through some real valued 8 cos 22 matrix. Now you want to pass it through your LDA model. Okay. Now if you just run it, you will get the thing. So let's see what this topic was represent. Now what is now if you see the shape of this thing, so it is a 3 cos 22. So what does this mean? So there are 3 components. So basically there are 3 topics, and for each of these topics, so there is a distribution of words. So if you just remember, in our corpus there are 22 vocabs and 3 topics. So basically it represents for each of these topics what are the probability it belongs to that topic. What are the probability it belongs to that topic. So this for each of these topic class you will find this thing. So if you want to see, you can print it. So okay, so this is the thing. So for the topic class 0, what are the probability for each of these individual 22 words? So it's not basically actually the probability, because sum of the value is 1 greater than 1. So probability cannot be 1 greater than 1. But yeah, so if you normalize this thing, you will get the actual probabilities. Okay. So this is just the thing. So for each of this topic class, you will get the probability distribution for each of these words. Okay. So same for the topic class 1, what is the probability distribution? For the topic class 2, what is the probability distribution? If you think this kind of visualization is not very helpful, you can do it with pandas library. So you can use it some kind of some small coding, and you can see, okay, for the topic class 1, what are the so for each of these words, so each of these 22 words, each of these 22, what are the probabilities? So again, so these are the not actual probabilities, but you need to normalize. Yeah, so for topic class 1, topic class 2, so you can see, so for topic class 1, so this bacon, this eggs, and this kind of things are high probabilities, and this dog, this all these things are jump, these are low probability. Similarly for topic class 2, some words are high probability, some probability. So this is how you can see. Now what you can do is that, okay, so now let's check. So for each of these topic class, what are the important words? So if you see for the topic class, so topic class 1, green, egg, sausage, ham, bacon are the important words. For topic class 2, today, love, blue, beautiful, those are the important words. For topic class 3, fox, brown, so those are the important words. So how do you get that? So basically if you just sort the words according to their probability score for each of this topic, you will get the top 5 values for this thing. So this is not difficult. You will get this thing. Now the thing is that now we will also understand the topic for each of these words. Now the thing is that it's not very interesting. So suppose I will give you a word, you will say, okay, so this is from topic 2. But what is this topic 2? So I need to map to some like human understandable words. Okay, so let's map. Okay, so if we read the word in the topic 1, we see, okay, so there are words which are mostly related to food. Okay, so let's map. So if you see some topics use one, I will map it to food. Okay, something like that mapping. Similarly in the topic 2, so you see some kind of sky, beautiful. Some I thought it's maybe it's related to weather. Okay, so if I find some topic with 2, I will map it to weather. Similarly from the topic 3, if we see there are fox, dog, brown, all these things. So if we see some words in the topic 3, I will map it to animal. So this is just for understanding purpose. Okay, now what we can do is that we already learned this thing from our training corpus, this 8 documents that we have at the beginning. Now also we can test how this model works on actual this documents. So if you see, if we run this our model with this training set, we can see what are the prediction for each of these documents. Okay, so for if they are saying document 1 is from topic weather, document 2 is topic weather, something like that, document 4, 5 is from food. So let's check. So is it really document 4, 5 is from food? If you see, okay, so go back to our actual example. Okay, so 1, 2, 3, 4, 5. So these 2 are 4, 5. So if you see, so these are related to food. Yeah, so clean breakfast, sausage, bacon, this, and I love green eggs and all this. So these two words are from food category. So it is kind of predicting correctly. Okay. Similarly, okay, so let's check another word. So for document 8, it's predicting key topic animal. Okay, check document 8. Document 8 is the last word. Yeah, so it is the last word, but I see it is not related to animal. It has some word related to food and all these things. But you can see, as our corpus is very small, so it is not always possible to learn the exact parameters from this small corpus. So that's why this kind of misclassification happen. But when in the real life you will run this algorithm with a larger corpus, I hope this classification will be more accurate. Okay, so this is the thing. Also you can see another thing. So what is the topic distribution for each of these document class? So what I'm saying, so if you see in the document class 1, so we are predicting the topic as weather. Okay, but there are other so basically there are 3 type of topics. So food, animal, and weather. So after mapping these things, so there are 3 type of thing, but we are only predicting, okay, this is from class weather, because we are taking the argmax, so maximum of this thing. So basically when we run the algorithm, we will get this kind of matrix. So for each of this document class, what are the probability distribution for each of this topic? Okay, so as we are taking the argmax, so that's why we are taking the maximum probability class. So maximum probability class is topic 2. So what is topic 2? Topic 2 is weather, so that's why we are predicting weather. Okay, but in the real life it is possible ki there are documents which can be from multiple topics. Okay, so that the example that I have given earlier. So if you see this IPL opening ceremony, the article from this IPL opening ceremony, it can be from sports class, or it can be from entertainment topic also. So in those classes, it's very important to predict 2-3 topics. Possible. It's not like that predict the most probable topic for this class. So on those type of example, so you can use this kind of table and then predict maybe top 3, top 4 topics from that. Okay, so it is as per your need, as per your problem. Okay, so now the time is that let's inference. So all the words are already we have seen. So now check the infer a new word. So we already trained the model. So now we want to classify the document. Another term. So what is the document? So it says the fox is lazy. So we want to classify what is the class. Okay, so if you see, so it is predicting the class is animal. Okay, so it is predicting the class is animal, so it is quite right. Okay. And if you want to see the distribution of the probability, so the topic class 1 has a probability something, topic class 2 has a probability something, but the major probability in the topic class 3. So what is the topic class 3? If you remember, topic class 3 is animal, so that's why it is predicting the animal. Okay, so let's do one thing. So let's add another line here. Okay, so the fox is lazy. Now run the example, and again it is predicting the topic as animal, but let's print the, so let's mark it as previous. So this is the previous distribution and it is the present. Okay, so now let's run the distribution. If you see, now see, there is a change in the probability distribution. Now the topic class 3, which is related to animal, is decreased a bit, right, from 72 to 62, but the class 1 is increased from 13.9 to 26.5. So what is this topic class 1? So if you remember, so topic class 1 is related to food. Okay, so if you see, so when we add some words related to food, the ultimate probability is ultimate prediction is not changed, but the individual topic class for each of this for this document is changed. Okay, so you can see, so yeah, so this from animal is dropped, but for in the food category it increased because we have added some word. So this way this kind of algorithm works. So I hope we will play with this code. So there are other codes are already available, in numbers of code are available. So there are blogs available related to this thing, related to Gibbs algorithm, Gibbs sampling, LDA. I recommend you to read all these things because it's not always possible to understand everything from a lecture. So then you need to read those things to understand, to build your basics. So, and always like do coding. So because if you don't do coding, you will not get the full knowledge how things work. So because when you are reading the algorithm, so you have some perception, but when you are implementing it, you will have the full thing. So how this algorithm actually work, and what are the flows, and where this thing fails, and all these things will understand better. Okay, so that's it for this week. Thank you. We'll meet in the next Tuesday, and I will link this this tutorial in the video description in the YouTube. Okay, thank you. Goodbye.